Welcome back, everyone. So in this section, we are going to take a deep look into performance with React applications. Performance is actually a very, very common thing that every developer faces at some point after building an application. We've spent all this time building all these features. We've written all this complicated code. We've brought in all these great libraries. We've architectured our application in a beautiful and readable way. Our application is beautiful. It's live, it's good to go. And then suddenly you try and navigate and you notice, oh wow, this is actually really slow. Well, why is that? Well, one big thing to remember is that there's a difference between production and development. We've been so far developing off of our local host, which means that all of our files is being hosted off of our own computer's port 3000 to be specific. It's very efficient for us to download all of our bundles and all of our files and our JavaScript over this because we're just developing locally, right? Speed is really quick. Internet connection doesn't really matter. But internet connection becomes a big issue, especially if we're building applications that must be hosted live, especially in countries and places that might not have the fastest internet. If that's the case, when we actually look at our code in production, this is now being hosted over some live internet connection that you own. If you find your application slower, well, this is actually normal because this is the nature of how code performs in production versus in development. If you have really fast internet, you might not notice a difference. If anything, it might actually be a little faster. But that's just a thing to keep in mind when it comes to performance and why we need to think about performance. Now, before we actually dive into writing anything on performance, there is one very, very key topic I want you to remember as developers going into these new careers, or if you already have a development career. This one thing regarding performance you must hold dear. Do not optimize your code ahead of time. Don't write performance code and don't fall for all of the performance tips and tricks that people write without a reason to do so. You only want to optimize your code once there is a problem. You don't want to get too eager and start optimizing your code right away. And there's actually two big pitfalls as to why this is the case. The first is that if you start writing code that you read online that tells you makes your code a little faster, you might not have even measured if your code was slow to begin with. You can only optimize code if you know that the code will be faster. And the only way that you can tell if your code is faster is if you measure it in the first place. So if you don't measure or know how to measure performance, don't optimize the code just yet. It's only when your application starts to slow down and you notice that there's problems, then you want to figure out how to measure it before you start looking at potential solutions as to why it's slowing down. So that's the first thing. The second thing is definitely to not over-optimize. Because when you optimize code, you don't actually know, for example, if optimizing the code actually makes it slower. So you might be like, oh, that makes no sense. I thought this optimized code was supposed to make my code naturally more performant. How can it be that if you optimize this code, it actually ends up being slower? Well, you have to remember when it comes to writing code that everything has a cost. When you write any of the code to optimize your code, you're doing something new. You're adding something to your code base that React or the JavaScript engine has to run in order for that optimization to occur. We'll definitely explore that more as we actually come across more use cases in both our React code and our code in general regarding optimizations, where I can show you an example of that. But that's why we actually hark back to our original point, which is that you always want to measure your code. You want to measure your code to see if the code you wrote to optimize it actually added more time to your total render versus reducing the time. So that's two main points I want you to think about. Now, going into the optimization of our performance, there is one first thing we're going to do. The first thing we're going to do is we are going to explore the concept of chunks. Now, the great thing about Create React App is it gives us code splitting and chunking right out the gate. Now, what is code splitting and chunking? What I want to do is I want to open up the inspect, right? I want to open up our dev tool. Right now, instead of it being docked, I've actually separated it into its own window because there's a lot that we want to see and we want all this real estate to look at everything that we're going to look at. This is going to be the place that we're going to measure all of our current application's performance. The first thing I want you to look at is this network tab. Inside of this network tab, you'll see that there is a lot of things that is coming down this list. Now, before you actually look at what these things are, there's a chance that you might not have anything loaded, and it's because you opened this after you loaded your application. And make sure that you're loading your Heroku application. So one thing to note as well is that when you open your Heroku application for the first time, after a long time of not opening it, or if it's the first time you've opened it ever, you might experience a 5-second or 10-second delay while Heroku boots up the dyno, that is the server that's hosting our application. This is just the nature of Heroku. It has nothing actually to do with our own performance optimization. And you don't really have to worry about people that are looking at your application if you find that it's slow from Heroku, because if they know anything about Heroku, which most developers do, is that the free tier essentially takes some time to boot up. Now, one thing I want you to do is I want you to do a hard refresh. If you're on a MacBook, hard refreshing is holding Command Shift and then hitting R. If you're on a Windows or a Linux machine, you hold the Control key and then you hit the refresh button, and that will do a hard refresh, which means that instead of relying on the cache for all the files that our browser has already downloaded, what it's going to do instead is it is going to re-download every single asset on this page. So we'll talk more about that right now. What are these assets? Well, if you open up your DevTools and you go to Network, you'll see that when our application booted up for the first time, that we downloaded all of these different things. What these things are is these are the files that represent our application. So this chunk.css is the CSS code that our application needs. So one thing that remember with our CSS and JS is that while we wrote our code in JS, when we actually built our code and then served it onto our server, which is our Heroku backend, and then whenever anybody actually needs to access our website, they're actually getting CSS. They're not getting JavaScript. So that's one thing to remember with CSS and JS. That's why you see this CSS chunk still, even though you might be wondering, why is it that we wrote style components and yet I see this CSS file? CSS and JS always compiles out to CSS in the final build. This chunk.js here that you see represents all of our actual libraries that we're running. So this is React, React DOM, Create React App, anything that we were using to build our front-end application is all held inside of this chunk. This main chunk is going to be the chunk that represents our application as a whole. So this is all of the React code that we wrote. This is all of our components. This is all of our sagas. This is all of the JavaScript that we wrote. And then here you'll see these are the PNGs, which is the images that this page requires. Now, if a user comes to this page more than once, so let's say instead of doing a hard refresh, they just do a regular refresh. Well, now if we go back, we'll see that it's actually relying on memory cache for a lot of these images as well as the fonts. So these fonts were originally from Google, as you remember. Well, now these fonts are also cached on the browser. So this speeds up the performance really quickly for repeat visits. You'll see that here the CSS is also in the disk cache. So that's the great thing about the CSS too, is that it will also leverage this, and you'll also notice that the JS files are smaller now. So instead, if we were to do a hard refresh and then go back, you'll see that earlier when we had these JS files as 300 something bytes, now they're in 796 kilobytes, which is significantly larger. So this just goes to show you that anytime a user comes back to our application, it will always be faster than when they land for the first time and they have to download everything fresh before they cache it for repeat visits. Now, looking at these chunks is the way that we have separated our code into these bundles of code. One thing to remember with this main chunk, though, is that right now we've actually downloaded all of the JavaScript code for our entire application. This includes the shop page code, the collections page code, the checkout page code, the sign-in page code. All of that code is actually loaded on the browser right now. But why is it that we need to actually download those if the user has not even navigated to those pages? They actually don't need to download that code. Would it not be great if what we could do is split that code up? Well, let me show you this image. Imagine this image is our application. So this is all of our component trees, right? This is our app. This is maybe our sign-in page. This is our collections page. And then imagine there were other nodes along the way that represent the other pages, whatever. When the user lands on our application, so they go to our homepage for the first time, they only need the code up here. They don't actually need any of the code down here yet because they haven't even gone to the page. The JavaScript is never run. What we want to do is we want to only give them the bare minimum requirements of the code that they need so that they don't have to download so much code right away. This might not be important if you have a really fast computer or if you have a really fast internet connection. But for those people running on slower devices, such as mobile phones, or if they're running on a really slow internet connection, little bytes here and there is going to make it significantly slower and a worse experience. So what we want to do is we want to chunk up and bundle our code, which is what's called code splitting. What code splitting means is literally as we explained it. When a user goes to the homepage, they're only going to get all the code related to loading the homepage. This includes the libraries, the CSS, whatever they need. If they go to any subsequent other page, let's say they navigate to the collection page, then they're going to download the code here for the collection page. And let's say maybe the collection page also naturally loads the collection overview. Well, we also want to give them this code then. We don't want to give them the code for the actual individual collections yet because they have not navigated to that page. There's no reason to give them the JavaScript code here yet. We only give it to them when they navigate to this page. So that's one thing to remember. And at this point, if they never navigate to the sign-in page, we're never going to give them the sign-in bundle. So this is a great way to optimize our performance. And the great thing is that this actually comes really quickly out the box set up for us with Create React App. We just have to modify our React code a little bit in order to actually chunk up our application. And I'm going to show you how we're going to do that. And the easiest way for us to test our optimization is to just make sure that when we look at this network tab, we see what it is that we're getting in terms of these chunks. So right now we see that we only got our main chunk, right, which represents our application, and then this chunk JS here that represents all our libraries. So let's see if we can break these up. Because right now, if you navigate to the shop page, you'll actually see that all we're downloading is just the images. But the chunks have not changed. We haven't downloaded any new chunks since then, which is up till this point. So if that's the case, what we want to do is to chunk up our application. So I'll do that in the next lesson.